And then if you, I don't think I have the next one. Oh, I do have it. And then what happens is you start going down in terms of the complexity of the organism. When you get down to the Drosophila fly 3' UTR, is the 3' UTRs are much, much shorter when you get down to the fly. So when you look at the ability to form overall structure, as you can see that the vast majority of those 3' UTRs would be considered poorly structured. So it's much less likely to have as many targets. But then the ones up here could still be very important targets, and it just has a much more well-defined function in the Drosophila. So it might be interesting to kind of move down to some of these ones where you can do mutagenic studies and things like that more easily to maybe identify specific functions involved with this or some other factors involved, other proteins involved in this pathway.
Is that correlated with the frequency of circular RNAs?
In terms of how many circular RNAs the
do you find
organism has? Or? Yeah, so our collaborator up in Penn, he actually works on the Drosophila circular RNAs. So the Drosophila has plenty of circular RNAs. And then you can get all the way down to some of the fission yeast have a few, fission yeast have some introns, and they've found that some of them can actually form a circular RNA. But again, in terms of, there's not many of them, and there's also not many 3' UTRs lengths, so it's probably going to be pretty limited, but we think, based on how conserved structure and gene homologs are between humans and mice, that we think it's likely active in mice as well. But because you can't make knockouts of these mice, you might have to do some conditional knockouts and things like that to see if it is involved in mice. Those are good questions.
Question over there?
So you showed at the beginning that UPF1 binds to the 3' UTR, but that's kind of dependent on translation, because if you get rid of translation, it'll bind in the main message. So I'm wondering if for messages that might not be translated as well or have low ribosome occupancy, do you notice that maybe those are like prone to degradation due to structure maybe forming in the coding region?
Yeah, so I'm still working on that because these folding programs take much longer the longer the mRNA gets. But I'm kind of now looking into I've looked into like translational efficiency and correlations with regulation. But I'm still looking into maybe some of the ones that are less translated. If the mRNA is structured as a whole, is it being regulated or not? So I'm trying to use my RNA sequencing to look into that. And then another interesting thing when you think about that is stress granules. And what happens is during stress granules, those RNAs are no longer being translated. So now the whole RNA would be able to form RNA structures and could be regulated. And what's interesting about that is G3P1 is actually a core protein in stress granules. So that's another topic we're going to venture into because everything's there at the stress granules, so it would be of interest to look at. And Anthony actually did his postdoc on stress granules, and our lab is stress granule lab, so it's kind of funny. I came here to do circular RNAs, but everything leads to stress granules, I guess.
Yes, good. Additional questions? If not, thank you very much.